So as we take a look at this inequality, it's already isolated. We need to make sure the inequality, or the absolute value, excuse me. So we take a look at this absolute value, we do need to make sure that the absolute value is isolated, right? Which means that it needs to be by itself with nothing added or subtracted from it. And everything else is on the other side of the inequality. So then I ask myself, I need this number to be less than 4 as a distance. So I'm going to draw the translation. This is not the solution. So I'm going to draw the translation of what this means. So here's my 0. I know that I have this number. It has a distance of 4. So it is x minus 7 over 3 when I take x. And if I take a number, subtract 7 and divide it by 3, it has a distance of 4. And so it's the positive 4. But also, if I do the x minus 7 divided by 3, it can be a negative 4 because that also gives me a distance of 4. But because it is less than or equal to, that means any of the things in this region will also be okay to use for numbers. So if I ended up with, I took my number, I subtracted 7 divided by 3, and I ended up with negative 3, that's fine because the absolute value of negative 3 is less than 4. So the way I do this is I sandwich my value inside the absolute value between the 4 and the negative 4. And remember, this is not the solution. This is just what it translates into. This is a sandwich. I'm not the tails. So then I need to get x by itself. Now I'm isolating x in the middle of this compound inequality. And so I have to get rid of this 3. So I need to multiply everything by 3 because I don't want that 3 right there. I'm not fond of fraction. Let's go ahead and multiply everything by 3. So when I multiply everything by 3, then I'm going to end up here with a negative 12 is less than or equal to x minus 7, which is less than or equal to positive 12. Again, I'm isolating x in the middle of this compound inequality. So I need to add 7 here, here, and here. I need to share out that 7. Everybody get equal shares of that 7. The middle, the left, and the right all get equal shares. So then negative 12 plus 7 gives me negative 5. And then x, which is less than or equal to, and then I end up with, what is it, 19? So my solution then, where a is the left side, well, what's the smaller number, negative 5 or 19? So you're going to put negative 5 right here, and then b is the right side, or the larger number. And so b would be 19.
Oh, okay. Just like the other problems, it just looks different.
Yep. How was that?
That was good.
Okay. What other questions might you have? So for this example, we have to make sure that the biggest thing is I see this negative x. That means when I take off the absolute values, I'm going to have to change the direction of the inequality. I have two things going on here, though. Because I have the absolute value, if I would have just had the absolute value of 6 minus x is less than 7, I could have done the sandwich, right? Like I did before the compound inequality. But I also have this 3 is less than or equal to the absolute value of 6 minus x. That's also happening. So I'm just going to work this one first. Because it's the sandwich inequality, that compound inequality. So I know it's going to be negative 7 is less than 6 minus x, which is less than 7. I'm going to share out that 6, so I'm going to subtract off 6 everywhere. I'm going to share that out. Both the left, right, and middle will get that minus 6. And so I'm going to end up with a minus 13 is less than negative x, which is less than 1. Now, I need to get x isolated. That negative there is not isolated. So I need to divide everything by negative 1. So I'm going to share out that negative 1. So negative 1 here, negative 1 here, and negative 1 here. What happens with the inequalities, though, is it changes direction, right? So this becomes positive 13 is greater than x, which is greater than negative 1. So that's that one. So we have that part. But we also have this additional part over here. And I'm just going to rewrite it as the absolute value of 6 minus x is greater than or equal to 3. Now I'm going to translate this into what it means. This is not the solution, so here's 0. Here's negative 3 and here's 3, because what it's translating is that I need this 6 minus x and this 6 minus x needs to have a distance. When I take x and I subtract 6 from it, I need to have a distance that is bigger than 3. So what I need is actually the tails, right? So I need to ensure that 6 minus x is less than or equal to the negative 3. That ensures I'm on the left of negative 3. That means my distance will be bigger than 3. On this side, on the positive 3, I have 6 minus x. I need to ensure is on the right-hand side, so it's greater than or equal to 3. So this part of the inequality guarantees that I'm going to be on the left side of negative 3. And this part of the inequality guarantees that I'm going to be on the right side of positive 3. So now I'm going to work these two. So again, I'm going to subtract off 6 here and here, because I'm isolating my x, so negative x is less than or equal to negative 9. Multiply by a negative 1 or divide by negative 1. Depends on how you look at it, so divide by negative 1. My inequality changes direction, so I have x is greater than or equal to positive 9. Now we're going to go and solve this, so I'm going to subtract off 6 here and here. Negative x is greater than or equal to negative 3. Divide or multiply by negative 1, which means I have x is less than or equal to positive 3. Now I need to bring all of this information together. So if I were to draw the solution of this side, I have here is 3 and here is 9. So that's where that part is. And then I'm going to take this and draw it underneath its solution. Its solution says I have to be greater than negative 1, but less than 13. So the solution, the final solution, is this region in which they're both shaded. Because it is a compound inequality, it is an and statement, it is an intersection. So it started with a compound inequality to begin with, so it is an intersection. So the final answer then is from negative 1 to 3 inclusive. And then I pick up again at 9 and I end at 13 non-inclusive. So that's the final answer of that one. And that's because I had the inequality or the absolute value sandwiched between two inequalities. So I have to break it apart into its two pieces. I don't get the opportunity to just do the compound inequality like I did in my first example. All right, so as we take a look at this, I know that my answers are from negative 7 and negative 1. Okay? What is the distance between those two? So it has a distance of 6. Do you all agree the distance is 6? So what's half of 6? 3. So my halfway mark there is 3, right? Would be a distance of 3 from each one. So if I go back this distance and I go forward this distance, what do you think that number has to be? So I have a distance of 3. So it has to be negative 4. So if I take a number and I subtract off a negative 4 from it, its distance had better be greater than or equal to 3. Want me to do that again? I'll do it with another set. Okay, let's try it with another set. So my interval is from negative infinity to, say, 1, union between 9 and infinity. First thing I'm going to do is I'm going to put 1 here, and I'm going to put 9 here. What is the total distance between these two?
8.
8. What's half of 8? So add 4 to 1 or subtract 4 from 9. The absolute value of x minus 5 is greater than or equal to, what is the distance? Well, the total distance is 8. But the distance from 5 to 9 or the distance from 1 to 9? How is that? Cool. Sydney, good?
So is 5 midpoint between the two?
Yes.
Okay.
The 5 is halfway between the two. Cool. Now, here's something. What if I had told you that the solution was between -1 and 7? How would you do that one?
Well, the total distance would be 6.
Total distance is what?
6.
Is what?
8?
8.
Oh, 8.
You're just asking if I'm awake. I'm awake. What's the halfway mark?
4.
So half of 8 is 4, so I'm going to take 7 and subtract 4 to get my position, or I'm going to take -1 and add 4. So Sydney, you said it's where? At 3. The absolute value of x minus 3 is less than, and what was my distance again?
8.
But I only want half of that.
4.
Cool? All right.